All right, so next up is actually going to be a different machine that has the exact same purpose as the previous machine. So we're still going to be looking at this language of all of these nice little bit strings that have equal numbers of zeros to ones. What we're going to see here is that we can actually design a machine that goes through this in a slightly different fashion. And what's cool about this is that it allows us to begin this compare and contrast discussion about number of passes, efficiencies, possible inefficiencies, just giving us different ways to do the exact same thing. And that's kind of where I want to dwell on quite a bit in this section, is that I want you to be designing multiple things that are going to have the same goal. And then we can step back and see, okay, is this one better? Is this one worse? How long is this going to take? Where can I improve this? All of those questions of efficiencies kind of bubbling to the surface. So in front, you should see the nice little machine actually generated. I don't want you to look at the machine too closely right now because we're going to build this thing up. But this tool becomes a really convenient way to showcase how this machine is going to operate. So that's what we're going to do now, is I'm basically going to step through the exact same string as before. So the 001101. And then we're basically going to try to like reverse engineer this thing to construct this little machine up on top. So the way that this thing is going to work is that that very first read it's going to do is going to be a 0, and it's going to X that thing out. And then it's going to begin marching off to the right. It actually goes all the way to the end of the string, turns around upon seeing the blank, and then begins marching on back to the left. As it marches back to the left, it's going to see that 1 and it's going to exit out. And then we're going to march all the way back to the beginning again. And then we're going to start this whole process all over again. So when we march to the right, it's going to find a 0 and it X's it out and goes all the way to the end, turns around, marches until it finds a 1, and then all the way back to the beginning. So now on my third kind of go around, it's going to march to the right and find a 0. And then on its way back, it's going to march and find a 1. And then now you can see that this thing is all X'd out. So as it tries to march across, it's not going to find anything. And on its way back, it's not going to find anything either. So it's going to move me into an accepted bin. So it achieves the same thing, is that it is a Turing machine, and it does accept this particular input of having equal number of zeros and ones. But the way that it goes about it is slightly different. This one actually has this kind of cute, classic zigzag fashion. So as I go from left to right, my mission is to find a 0. When I go from right to left, my mission is to find a 1. What you can see here is that because this string initially started with 6 characters, it's going to have to go across this thing 6 times. So find a 0, find a 1, find a 0, find a 1, find a 0, find a 1. And that we don't get any savings by finding the 0 early. We actually did get that in the last example, is that if we find a 0 and a 1, then we're going to go right back to the beginning very quickly. We didn't have to go across the entire string. This one, we're stuck going all the way across and all the way across. It's this chaotic back and forth action. So it works, but then that question of, is this efficient or is this not efficient, then begins to come up. So again, that's the big alarms that I want you to be thinking about. So what I want to do here now is I want to jump into the written version so we can design this little machine. So pretend that you didn't know what it already looks like, and then we'll see if we can make it all work. All right. Ooh, twisty, holy schmolies. Hopefully that didn't go super crazy as I twisted my iPad. And let's go ahead. All right, so what you can see in the notes is I have this kind of handwritten version of how I don't jump around. It becomes kind of a convenient pencil and paper version of it, but it begins this quest. Once we have the little machine built, then obviously the online tools become far more convenient, but until you have the machine built, you maybe don't know how the machine is going to work. So here I'm trying to represent that movement. So find a 0 on the left-right movement, find a 1 on the right-left movement. So that's what I want to do in the actual design of the machine. So let's give it a new color. I don't know, let's get it purple. I don't remember what color I drew the last one in, but we'll go this one in purple. So when I'm coming in on this machine, my very first quest is to find a 0. That's mission 1 as I go from left to right. So I want to seek a 0. If I don't see a 0, I'm going to sit and spin over and over and over and over and over and over again. So that means if I see any 1s, I'm not going to change it, but I'm going to march to the right. And if I do see some X's, which will become more important later, I'm going to jump over it and keep on marching to the right. I'm going to leave this quest of seeking 0 only if I see a 0. So if I read a 0, I'm going to change it into an X, and I'm going to keep on marching to the right. And I'm going to go all the way to the right, all the way until I see the end. So my new mission then becomes seek end. So find the 0. Great, awesome, you found a 0. Now go all the way to the right. So you're going to keep on jumping forwards on absolutely anything other than the blank. So you see a 0, keep on marching. See a 1, keep on marching. See an X, keep on marching. So again, it's that kind of weird notation of the arrow's pointing at nothing, so I'm not going to change anything. There's technically a little comma to represent that I'm going to have a 0 to nothing, but then I'm going to march to the right. Basically, we probably don't want to use R's and L's as tape symbols because R's and L's are going to represent movements, so we don't want to get confused there. But a little comma represents that's actually happening. All right, so once I get all the way to the end, well, first I need to know that I got to the end. So the end is represented with a blank. So if I see the blank, I'm not going to change it. I'm just going to change directions. And my new mission then is on my way back, I want to find a 1. So I'm now going to begin seeking a 1. If I see absolutely anything other than a 1, I'm going to keep on spinning here. So that tells me if I see a 0, great. Keep it around, keep on marching to the left. If I see an X, great. You've already crossed something out, but keep on marching to the left. In the weird scenario that you do see a 1, and by weird scenario, I mean the good scenario, is you're going to see that 1, you're going to change it into an X, and you're going to keep on marching to the left. So you want to go all the way to the beginning of the string. So to keep marching, you're going to then seek beginning or seek start. So we're going to enter a new state. And as before, keep on marching until you get all the way to the end. You see a 0, keep on marching. See a 1, keep on marching. See an X, keep on marching. Read anything other than a blank, keep on marching to the left. If you do finally see a blank, things are great. So the blank tells you that you've made it to the front. Leave the blank alone because that's your placeholder to know that that's the start, but you do have to change direction into a right. So that's the big general structure of how this thing works. So you're going to go across, find a 0, and then on your way back, you're going to try to find a 1. What happens though is that if you go all the way through and now you're seeking 0s, and if you don't find any 0s, you may be tempted to think that you are in good shape. Everything is awesome. You didn't have any 0s, they must be all matched up perfectly. Well, that only happens if you cross on the 0s. You still then need to come back and cross on the 1s to make sure that that didn't break. So there's actually going to be a 2-state process that brings us into final acceptance. And I'll dwell on that in a little bit. So if I do see a blank, that means I've passed the 0 test. So if I see a 0 on the way right, I'm going to be like, cool, I don't have any 0s. Life is great there. But now I'm going to march all the way back on left to actually ensure that I don't have any 1s left behind. Because that seek 0 just jumped over 1s. So I could actually get all the way to the end and have some dangling 1s that were unaccounted for. So what I'm going to do here is I'm going to have this new state, which is kind of another seek 1 state, or I'm just going to call it pass left. And what's going to happen there is that I'm going to keep on dancing backwards. And the hope is that I only dance backwards on X's. If X's are the only thing that are on the board, then I know that there are no longer any 1s. And then if I make it all the way to the beginning, life is great because I would read a blank and I would do nothing to the blank. And I could technically change directions to the right and end up in this final accepted bin. So we did have to add one extra caveat here of there is this extra pass left. But if you think about having just the input stream of just like 1, 1, well, if I was at 1, 1, my pointer would say, okay, skip over the 1, skip over the 1, and then end up at the blank, which would say, okay, move into here. And if that was my accepted bin, you would incorrectly be accepting just a string of all 1s. So as I begin to march on backwards, I would have found the 1, and then this thing would have blown up in my face, and that's exactly where I would then fail. So if you go back to the online tool, so if I new share this thing, Turing machine visualization tool, If I load this thing up, you can see exactly how those things all came into play. So I find a 0, I'm now going to seek the end. When I come backwards, I'm going to seek a 1, which I actually find right away. And then I go back and find the beginning. Then I find a 0. Find the end, find a 1. Find the beginning, find a 0. Find the end, find a 1. So here's where I'm going to do a pass to make sure that there are no zeros on the board. And then on my way back, I'm going to go and do a pass to make sure that there are no 1s on the board. And if those two checks work, I'm going to move into acceptance and I'm done. If I were to try with an extra 1 at the end, it's going to go through it a little bit differently. So I'm going to have my 0, come back, find a 1, come back, find a 0, come back, find a 1, come back, find a 0, come back, find a 1. And now what's going to happen is that it's going to begin the seeking for a 0. Well, it's not going to find a 0. So it's going to keep on marching. It makes it to the end. So it's past the 0 check. And then when it's looping backwards, it's actually going to begin this quest of looking for a 1. Or hopefully not finding a 1, I should say. My hope is that I only find X's, but in here I actually find a 1, which causes my machine to break. So we're dead at that point in time. So if I get rid of that 1, you can see where the double pass came into play. So pass, pass. I had a shorter string, so I don't have to click my mouse so many times. All right, so here we're going to do this final pass. Definitely no zeros. My hope now is that as I go backwards, I only see X's, which I do, and then it moves me into a final accepted state, and things are great. So it's a slightly different way to go about the exact same language. It has one additional state. So if you're thinking about efficiencies, it has more states. It has few more passes than the previous machine happened to do, but it's maybe a little bit easier because these things are all nicely linked. There's no crisscrossings of states. We have everything very tidy. Other than my final breakout, everything has this nice just square. There's no like, well, I found a 0, now I find a 1, or if I find a 1, now I find a 0. I'm always finding the 0 first and then finding a 1. Find a 0, find a 1, find a 0, find a 1. So it's different, but also very similar. So we get this nice kind of cute play by designing a few different machines and trying to see what they're all about, and then really using this as kind of a springboard into our discussion of efficiencies and all of the fun that's going to come from there.